we just speed run through presentations. If you want the longer versions, we recorded in books of gems, transcript afterwards from any of the SVCs website. I encourage you to go check it out. The goal of that talk was trying to map what's going on with agents and MEV, but not just in the sense of how we can use agents today to play the MEV games, but more also maybe potential future MEV activity or MEV type behaviors that we will see due to the emergence of agents. And so I broke it down into 3 tracks. The first one is what we can see today already, we can use today. The second one is what we should be aware of when designing agentic networks. And the third one is really what MEV could potentially arise from AI-based activity like decentralized trading or the prediction markets. So that's the idea. The AI for MEV is something we've been trying to look at flashcards. The theory of this topic is that if you look at the literature, there's not so much work using AI for an MEV type of activity. And the hypothesis that I have is that it's because there's not so much valuable data that's available in the public here, and a lot of the valuable data flow and the bundles and it lies in proprietary datasets. Okay, so we can play with them, but not everyone has access to it. So there's 2 basically things we can think about in this direction. First, confirm that you can do something with it, and that goes on. If you look up the Flashcards website, the writing at flashcards.net, you'll see that the year and a half ago, we started looking into the idea of parallelizing a block builder. And in very short, the way it looks like, you mentioned the block being processed in 2 phases. The first one, you try to identify functions that can fit with one another. And once you have these groups, so all different colors here, we try to resolve the ordering within these groups separately. That's what we call a parallel block builder. So you don't parallelize every execution, you just parallelize the resolution of the conflicts.
I'm gonna try to make sure everyone here from different background can be on the same page. So raise your hand if you know about block voting, how it works. Sick. Okay. So I remember I tried to explain this to you at like 2 a.m. in this hookah lounge over extremely loud, aggressive music. And I think I failed, but you keep on asking me a good question. And then I realized I actually just forgot to ask that question to myself, a system prompt, which is what is the object, what's the objective function?
That's very fresh. So I have, yeah, we can look at that. So the crude form of it is to say, I want to be on the biggest block, right? So the MGT function can be maximize the media extraction from the block. That would be single objective, okay? And you can do that in many ways. Basically, what you're trying to do here, just to be clear, is you're trying to swap out each of the algorithms that you see in these boxes. So these are the state-of-the-art AI ones that we have already in production. Some just run all of the computations. If the group is very small, you can just write all of the possible orders, for example, and that's how you solve your conflicts. Some just do regular computations, right? Or some just try to pack, like in a knapsack-like fashion, you just really try to pack the lock and do your best with the time that you have over here. And so, if you have this function, as Tina was saying, you can just point like any type of optimizer to this problem and say, be the best block you can find. So you can do that with JSON algorithms, for example. It works. We have evidence that it works. That's what's in the blog post. It should work with releasing. It tends to be slow. So it's good to identify how much theoretical MEV you can extract from a block, but it's not very good at something we would put in production, for example, and be able to kill the block in under 2 seconds. On the other hand, you can also try to throw some reinforced learning with it. We're very fortunate in this setting to be in a perfect simulator type of scenario where the EVM allows you to perfectly simulate what will happen. So you can just throw an alpha 0 type of NCPS algorithm over this playbook, and hopefully you can learn a better strategy to place orders within the block. Work in progress, we have no confirmation to check, but like in theory, there's a reason why it shouldn't work. I'm going to skip through the auto research. I don't know everyone here knows what auto research is. Yes. The interesting thing when you try to expand this optimizer to an auto research type of scenario is that I try to think about it as like removing more and more degrees of freedom, or adding more and more degrees of freedom to the optimizer. So in the GA or in the RM, all this very much guided. We've got this function. Here in the auto research, it's kind of like no guardrails if you don't do it, right? You can modify completely the whole code of the mobile builder. So intuitively, latching just on make me the best block is probably not good enough. You need to add more constraints to your fitness function. Otherwise, very likely, we've seen that into various auto research scenarios. The AI agent will try to find shortcuts in the problem, right? So we'll probably rediscover sandwiches, or we discover threading and all the kind of things you probably don't want to have in the public facing builders that build the cycle. So you need to inject more constraints and guide your optimizer vehicle. So what's interesting for us here today at a brainstorming problem, for example, is how do you do that? You can try to, that's what I have at the bottom here, you can try to encode the multi-objectives within the optimizer itself, which is not really what people do with those research. You see the latch to single grid fitness functions, over the course of sometimes generalizing multiple constraints into one scalar. Then potentially it's like more things to do. I'm sure other course we'll talk about it and Brandon later. You can try to think about it as like a AI safety scenario where you try to observe what the AI is doing in the latent space, essentially, to try to identify and isolate harmful scenarios, right? So that's, again, just the direction. No validation making could work, but in theory, that could be a very nice approach to looking in this direction. Okay, so that's kind of like the stage for what we can do even like today, just like on this sort of DMOS agents and do it like by the end of the workshop. What I call MEV aware AI, second phase, is once you have these auto research type of groups, and we've seen that being deployed on the web, inherently, you can do that on your laptop if you want, but the real goal would be to have a huge swarm of agents across the internet collaborating towards a certain goal. And there's two assumptions here. Either all of these agents are aligned and harmonious, right? They are willing to contribute to this shared goal, and maybe they can work. And I think that's what some people do. Like if you look at Ensu's auto reset home profit rates on those gets something to making that, and people would be willingly contributing to this network, kind of like what we had back in the days with Sega at home, 40 at home, where you are just actually able to compute towards the shared objective. Now the question is, can you harness these agents that might have misaligned incentives across the internet? Right? How do you make sure that they can all contribute towards a shared goal when they are actually competing for a given reward? And in that case, imagine that these guys might even be not even using like an Aristotle information merging setting, but more looking for the best current results, grabbing a task and racing towards improving the current best state of the art on the problem we're trying to solve. What happens in that case is you can only compete on hardware and on latency, right? And that's something that we've seen in the markets we're dealing with MEV, that basically turned into a latency race where the richer, the more sophisticated actors start capturing a lot of the value because they have the means to initially sellable hardware, faster communication channels with the coordinator that verifies the updates. And we don't really want to have that road yet to build a new network so that everyone can participate early without necessarily having the same level of sophistication. And what we've learned from the MEV playbook in these cases is that if you want to avoid latency races, you can try to use auctions to make these agents compete. So in that case, we're not talking about maybe top of an auction, but you will need to have a way to turn the same ID of the type of auctions we see about building in maybe the confidence that agents have in their contribution, right? So that's again an open question, something we can think about. What would it mean to not only contribute to the shared objective, but also to potentially express your confidence in how good your contribution would be by placing a bid towards it. Another thing that can appear from what we see in the playbook is this idea of front running by observing the behavior of other agents. And that's something that's very central to our week at SBC for flashcards, in the sense that we have demoed a new network called Alimon, which is an anonymous broadcast network where anyone can participate in the demo that we have. It's a chat, so you can send a message if you are anyone knowing who you are in this network. But more than just knowing who you are in this network, you want to use this type of primitives to avoid your metadata from leaking. So I should not be able to identify who you are when you're talking within the network and trying to leverage that to front run you or to prevent you from talking. If I know you're very good and you're very close to solving a task in the auto research scenario, for example, and I want to delay you because I want my contribution to get it first, I should not be able to do that just based on what IP you're sending from or what time of the day you're sending from. It kind of makes sense in a more scenario. So this is typically something that we've seen, and then we always it should be important in MEV on chain, and probably a primitive that we want to reuse and apply in the context of these auto research HT tools. I think Phil may be the best person in the room if you want to talk more about these topics, especially in the sense of what's the current throughput we can expect and how that we scale up to the type of application we here. Finally, unless you want to go on.
I think we can leave questions till the end, but I was going to challenge you a bit because I felt like your first section and then the second section, your first section was AI for MEV, and your second section was MEV aware AI. But here, I feel like it's also just AI for MEV because agents today, do not have economic rationality, and that there's essentially we're using it as a tool so it's still AI for MEV. So I was going to, before you go into your AI and MEV, the third segmentation, how did you define out the first and the second?
So the first one is really a very basic. How can you harness AI in the sense of coding agents more than something generic to either coding agents or the optimization methods we know from the AI literature to solve very concrete MEV type of problems and in particular the problem of building. I think that was really the limit boundary of this first AI for MEV. Whereas the second one is more, we have these early forms, early networks that are primarily where the agents live, and it's not something where humans are meant to directly interact. So how can we avoid making the same mistakes, the same design mistakes that would lead otherwise to early forms of MEV like PGAs, like gas auctions, and that would be detrimental to the whole network, increasing feed and congestion for everyone else. So it's more observing the same type of communications and interactions that we've seen on chain between MEV bots, and then we use this knowledge we've gathered to avoid making the same mistakes when we design Agentic first networks on the exchange.
Cool. And how about your third segmentation?
So the third one is really the new types. What I is very like describe. You don't have the aliens that it could happen. It's like more of a local brainstorm of what new forms of NE could arise from the very way that AI and agentic networks work in our architecture. And so one that I find particularly interesting is kind of like the evolution of what I was working on previously, is this idea of decentralized training, which, very interestingly, I don't know how long you've been in the space, but every time there's a good cycle, people trying to pair AI and crypto together, and most of the time it's bullshit. For the last time, maybe, we've seen a valuable contribution emerging from what I would call primarily the crypto community to the AI community. The reason was not necessarily the organization on this slide, but a lot of people have been trying to tackle decentralized trades. How do you train a large language model, for example, across the internet? And the issue in this type of scenario is that you need to communicate very often and relatively large hangouts. And the way that AI training is set up is not meant for that, right? It's optimized for multiple GPUs to communicate on proprietary links in a single data center. And so all of the literature of optimizers and the innovation tricks that we have was absolutely not suited for these kind of settings. So these people have been in particular Burleys and News and like all the other teams that are in the forefront of these efforts, have been designing new training stacks in a way that are internet first, and is compressed the amount of communication you need to make and the frequency at which you need to make communications between different nodes in a centralized training network, which is great. The cool thing is, it's actually relevant for the big AI labs as well, because they've grown to the scale where they can't really fit training within a single data center anymore. So we're starting to do bottleneck by communication across data centers as well. And so now we're looking at adopting the same type of primitives to suit their needs across these data centers within the country or across the world. So it's kind of fun to see finally a contribution that emerges from our concerns, mostly driven by ethical concerns at first, to have the possibility to train networks on the internet, and being adopted by the more centralized firms, more practical concerns going. That being said, okay, assuming people are actually very familiar with the Tensor, this network of different sub-networks.
With anyone here as a minor at Cancer? Anyone here doing decentralized training? A bunch of a few hesitant hands. Anyone here heard of it as a scam? Sometimes when unfortunately, as a great researcher working on the crypto side, a lot of the examples you are using, later on, they were John Bus scam for obvious reasons. If you have a token, because for those that will come down, but as I think that as designers and researchers, like market structure and whatnot, these are interesting human phenomena of just like the dynamics of markets. Okay, so yeah.
So what happens in these networks, if we simplify, there's one in IQ Conceptual that tries to do exactly what I was describing, so trading and then leg across the internet. You have miners that have space to be part of this network, and you have validators that try to verify the completion that has been made, if we simplify what's going on. The issue is that the validators are incentivized to vote towards the global consensus, okay? And so if you just stick to that kind of objectives, what happens is you basically incentivize the bank players to stick to what everyone else is saying, even at the expense of not even doing your computation. Okay, so you just try like either agree with what it is saying, or just like copy what the neighbor has been saying. And that's been studied. I'm not going to walk you in the details of like these conclusions, but like one of the things we observe is if you can commit to your score first before anyone else revealing their scores, it's kind of like one of the things people have been trying. Issue with that is that it also goes back to a latency race. If I'm the first that is able to know what is the new state agreed upon by the whole network, I'm getting an advantage over the other nodes and miners instantly. So coverage reveal is solely part of the problem, but not everything. So again, here in the ZRX training, we should see MEV arising because of how the network is being coordinated. I think that makes sense. Again, not backed by data, just like a thought exercise. If we want to try and like observe that in the real world today, let's go. More interesting in AV, these networks also operate as PMMs in the way that they are deciding the emissions of the bigger network, of the bit tensor network token. And the issue with that is if you, again, think about how the network is being rewarded for progressing, you can very easily try to pump your subnetwork to kind of like have a pretended activity that will give you higher rewards from the large network. And thus, by doing so, you gain control over the bigger network. And that is something that we've seen as well in the MEV space. People have been studying cross-domain MEV, for example. And what boils down to what happens in this case is that it's again mostly very sophisticated players that can allocate both resources like hardware, manpower, but also financial resources to capture discounts or opportunities. So in the decentralized trading space, we can also expect to see the same kind of dynamics at play. If we don't do anything special, that is a new type of MEV that could arise, but very much resemble what we've seen before on the crypto space. Another one that you must be aware of, and again, there was like a very interesting presentation, SBC on that, a bunch actually. In prediction markets, the issue is how do you resolve the market itself, okay? And the one thing I want to remember from that issue is that yes, we've seen evidence of markets being like poorly structured in a way, so there's imperfection in these markets, hence why there are arbitrage opportunities. But I think to me, what's important is the main further problem of these prediction markets is no one really agrees how to solve them today. Okay, so it basically boils down to an oracle kind of problem, and again, we've seen that in the AV space before. So really, a very clear direction if you want to improve prediction markets is trying to propose more robust resolution mechanisms that don't rely on a single person or a single entity, for example. And to make it concrete on how you can try to do that, but still not reach what would be ideal, there is another subnet in the tensor called Luminous. They're doing very cool stuff, trying to incentivize agents to forecast the outcome of the new prediction market. So you can think of it as like a centralized oracle that would resolve before the market itself to either guide you as a trader on what markets you should be on, or that you could use that as one of the ways to use other markets. But again, the issue is how do you grade the submissions that the agents in these markets are making? Okay, and that's the current form of it, they need to. You still have this split between miners and validators, and in that case, the validators need to observe the predictions that the agents are making to decide how good they are. The issue in that case was that the way they are having the validators rank the submissions, it applies for the validators to have access to the strategy of these miners in plaintext. So if you've ever, interacted in the MEV space, you know that, it's probably like the last thing searchers would want to reveal, how the strategy is basically the most valuable thing they have. So even though the ID and maybe like the dynamics are interesting and could be a valuable contribution to operation markets, it's not sustainable because of all the behaviors we've seen in the original AVD space. So improvements to make here, and again, AVD is a multidisciplinary topic. We've not talked too much about privacy, but that's clearly an example where you would benefit a lot from privacy, and in particular, called programmable privacy. So potentially, zipping these validators within keys, within GPU keys, or with programmable cryptography traits. Last point, I think, yeah, perfect, is an analogy that's again not verified, but something we can try to explore with further today as well. It would seem that the way the AI token market is structured starts to resemble what happens in the DeFi market as well. So instead of just sending a transaction for a swap, you're sending an intent, and you ask the solver to give you the best quotes for this intent. In the AI space, you also could do the same thing, right? You try to use the router to get the best model of the next price, for example. Now, what's interesting is who captures the value in both of these situations. If you are a good router, eventually your incentive is potentially to stop routing to this other device, but to have your own model and to route into to capture a bigger margin, right? I'm aware if that happens. I think Dimars, you looked a bit further into these topics of routing. Do you want to say a few words, or?
You have an entire talk on it, right?
Yeah, I have an entire perfect. So spoiler alert,
But-
no spoilers.
Do you want to spell it?
Do now.
You do?
Wait, sorry. What's the question?
But can you just say a few more words on like what you observed from the token routing?
Yeah.
You don't have to.
I don't have much other than a lot of people have been building mechanisms to verify that you're talking to the agent you intend to talk to. So yeah, specifically with a router, right? Like you could be talking to it and you think you're talking to the new Kimi K3 Max. But the first prompt, they give you Kimi K3, and then after that they give you all the done. So I think a lot of people propose for like ways to use deterministic seed in the model with like a prompt that you try hit it with every like 10 seconds to make sure you're still getting to the right model. And then there's a bunch of things on like cost optimization where people are like rapid prompts.
I guess it raises interesting questions as well that we can have for the rest of the afternoon, which is, do you really want a specific version of the model, or do you want a good enough level of quality? And in that case, are they really ranking you by routing your request to a cheaper model that still does the job for you? If you can't tell the difference, is it good, is it bad? Let's see. That's pretty much what I had. So you've got this evolution, okay, like so now the AI for MEV, as I was saying, we're a bit in a non-sophisticated scenario. We're just trying to develop new strategies. The unlock here is to have access to data. And you can think about it as well as a building gyms for these environments. Very much something that would be valuable in the adoption. Second one is really applying in the AVD playbook. So designing options, for example, for those type of behaviors that we see, really interesting. And the last one is really observing what happens in these networks today. So really like how the decentralized trading works, how information market is being resolved. That's where the innovation comes. So not sure there's like really products to make here, but it definitely like a bunch of papers to be written in this direction. And there's like a more elaborate version of these slides on the screen at the back of the slide. And I'm going to give you some prompts of, pretty cool research topics where you can enrich your agents against. Thanks for listening.
Very quick question. So the thing about copying people's like votes and messages in the big text example, it reminds me a lot of apparently people are doing this in Solana, where they'll just wait for someone to vote and just copy the vote and sign it. And so that's a consensus problem, right?
It is very much.
AI problem. But you're saying AI training is using.
No, I'm saying isn't all consensus only done to MEV?
It's like MEV's instability and consensus security.
MEV aware consensus.
For those who may not know the winks that's going on, right? There was an OG paper that defined the MEV by this long hair guy whose hair was short, called Flash Voice 2.0. And it was a figure on MEV and consensus stability. And so, like, I think that's one of the kind of a reason going for me recently to go down this rabbit hole of agentic MEV was, I think, at some point a few months ago, Brendan, who's sitting over there, my absolutely malfunction, asked me about essentially he's all of a sudden interested in consensus, and me and another team was like, what? Say more. Why? And so then we got on the side, a lot of these are called Jonathan has been saying a lot of these stuff workers. So I'm gonna come to our friend Sean here from Sigma Prime. They came on before your clients and also Loon Security. Just a quick gut check. What's your take on this framing, and also any thoughts?
The framing of MEV as its consensus.
Well, the kind of agentic entity framing, but sure.
Slides or can use mine.
Yeah,
I have them. I got some of your slides.
Yeah.
Yeah.
Instability to
Just a
consensus.
second.
Basically, because consensus at the end of the day, we're relying on people being economic actors, and that is kind of just an economic force that's kind of outside the protocol. And lazy validating is definitely something that we think about. And we think about it in terms of if you're going to rely on people doing the right thing to actually validate it, you have to make it as cheap as possible. So I don't know how exactly that applies to the same problem in the agentic space, but that's fine. Let's probably think about it.
Do you think, do you think that's the lazy behavior is mostly down to how expensive it is to, or how complicated it is to perform the task?
We do think of it in terms of if you make this thing too expensive, for example, if you're a validator, verifying execution state, that's the expensive part. If that's too much overhead, then people might start forking clients and just not do that, and same as on Solana Road. So we think of it as a scale, but we don't have a concrete model of what's too much, what's too little. It's sort of just set all these things up by default from the clients and hope people do them until we start to hear about them forking them or not doing them. So
It's interesting because would you be satisfied with a PDS type of solution where the validator outsource the work to induction of very specialized bug readers type actors?
You mean the present day, well, the verification component, no, but if we have, ZK proofs at L1, then all of a sudden it doesn't matter for the validator, you can just verify the proof. And at that point, it's super lightweight because we don't expect everyone to act on the state, and it's less of an issue.